see run. Now in this case we complete calculation finish load reinforcement concrete design and reinforced concrete design finish. Okay, without any error. You can check for the displacement. Displacement is 0.22 meter. Here you can check again. Maybe you can increase length of pipe and force. Click on force, load combination, click on Y and set. Now let's come back and change the load. Now I want to input the load. Input the point load. Now input the point load. Minus 3,800 and H to 100. Click on auto scale. Now delete this reference point, copy and pass. Change the value to minus 500. Okay, click on finish, click on save, analysis, OC design, click OK. Now let's check. Delete. Now you can check a support on 0.14. Okay, you can delete it. So run it again. Now complete analysis and design without any error. You can check for the force and ultimate load combination. Y. Okay. Now you see in the first tutorial in the first analysis we just assume it a linear load distribution on pipe cap. Now we check it. You see the different load distributed on the high. Now in the case we got the new internal force. This force is the MY. MY, the maximum value. At the top is 44.3 kilonewton, and at the location you can check on value on diaphragm. You can check the value maximum is 63.47. Now you can check for the axial force SX. Click on SX. Before you run analysis and design, you have to check about the mesh size. You can check about the mesh size. Click on the manage mesh, and mesh size we use 0.8. okay, we use mesh size to 0.8. you can check my tutorial. Now we want to use data L, node spacing is equal to diameter of ball pipe is 0.8. now use 0.8. click OK. Okay, after you correct the mesh size the same with the pipe diameter, you can come back, run analysis and design, click OK. Now let's review about the force, ultimate force, MY. Again, MY. You can check H, MZ, SH, axial force in pi. You can check. Also you can display the moment and force in a pi cap. Now let's check MYY in pi cap, MHH, MYY. Now you can check on displacement. Now we'll check on the serviceability. Okay, let's check. The displacement is around 0.00 is 1.7 centimeter for the settlement. You can check about settlement and animation. Click seal. And now after you complete for analysis design, you can check analysis design in GAD. You can click on reinforcement, longitudinal reinforcement, The case is a minimum reinforcement. You can check another direction. No. For torsion, no. You can check rebar in pie cap. In each direction, look for CH. Look for CH at the bottom. Look for CH at the top. It's the same. And look for C5 at the bottom. For C5 at the bottom. Look for C5 at the top. You have 30.86 millimeter per mat. You can check how much rebar you in the pie cap millimeter. Now change unit to millimeter. 1430. Now I select dB 16 calculator. In 1 meter you need 7.11 of the rebar diameter 16. Now let's put 1000 millimeter divide by 7.11. Use spacing 140 for the main rebar. 140 millimeter at the bottom and top of the rebar need in pie cap or rebar requirement in pie cap. You can check and compare with the minimum rebar reinforcement.